All right. Hello, everyone. Welcome to the first technical community call of 2026. This is where we bring Hedera developers, Web3 builders, and technologists key updates and insights about technical topics. So we're glad to have you here with us today. I'm your host, Ed Marquez. I lead the developer relations function for Hedera at Hashgraph. And Hashgraph is that firm that is behind key initiatives in the Hedera ecosystem. Now, before we go into the topics and intros for the day, I do want to provide a few housekeeping items. One is that we're streaming this call to multiple channels. So please like it, share it, and engage with it. We're live today, so we certainly want to hear from you in terms of comments, in terms of questions. And then there will be a Q&A after each segment. And of course, at the end, if you have questions. So please put those in the chat throughout the session. This is also being recorded so that you can share it again. Also, you can go back, watch it, record it, or study it in your own time. And I do want to cover a couple of reminders. One is you can sign up right now for the Apex Hackathon, Hello Future Apex. So if you're looking to start the year strong with a hackathon or returning to one of those Hedera hackathons, Apex is that opportunity with $250,000 in prizes for winning teams and a great opportunity to network, build, and develop those skills for building with Hedera technology and blockchain technology. The other reminder I want to share is that Hedera Dev Day is just around the corner, and that's going to be in Denver, co-located with ETH Denver on February 17th. That's a Tuesday, so we're looking to see you there if you're going to be at ETH Denver. So with those housekeeping items out of the way, I do want to welcome to the stage our speakers and go over the topics for the day. So welcome, Michiel. Welcome, Keith. So I'll pass it over to Michiel first, and if you could do a quick intro about yourself, that'd be awesome.
Cool. Hi, I'm Michiel Mullers. I'm also part of the dApp team, and I mainly work on the educational side of things. And I'm also maintaining and helping grow the Hiero CLI, which I will present today.
Hi, my name is Keith Cole. I'm a product manager at Hashgraph. I work on a lot of different things, including identity, consensus node, mirror node, SDKs. Also, for those of you that attend Hiero, you'll see that I'm quite active in both the TSC and driving HIPs and stuff like that. So it's great to join this call.
Absolutely. Great to have you both today. And then in terms of topics, Michiel, he's going to cover developer tooling, which is very important, for those building in the ecosystem to drive that flywheel that makes it easier for developers to build applications that will enable utility and adoption of the technology and bring value to society. More specific on dev tooling, he's going to cover the Hiero or Hedera CLI, which is a command line interface tool. But I'll let Michiel cover that. And then from Keith, we're going to hear on a very fascinating HIP, which is going to be hooks. And then we'll let him cover all the details on that. So let's start with this first segment. And so Michiel, over to you.
All right. So before I dive into the CLI, which I really want to, I will give a quick reminder as well about the namespace transition. Since last year, I think February, we've been communicating that we are transitioning some of our SDKs to Hiero, which is the JavaScript SDK, Rust one, and also the Java one. So a quick reminder, we are still in the dual publishing phase for the JavaScript and Rust SDKs, which means that we are still publishing these SDKs on both the old namespace, which is Hashgraph, and also on the new namespaces under Hiero. And the cutover for the Java SDK, that will happen in April. So it will immediately switch from the Hashgraph to the Hiero namespace. The big extra reminder here is that initially we had planned that we would hit the target date for dual publishing in February, but this has shifted slightly. So dual publishing is extended by 2 months. So this will happen mid-April, same date almost as a single step cutover for the Java SDK. So quick reminder to update your dependencies to make sure that your SDKs keep working in your applications. So then it's time to move into the Hiero CLI. And for those that don't know the CLI tool, I want to give a quick introduction to it. First of all, it's a great tool to simplify your environment management. It's very good for creating scripts that have loads of commands in it that can create accounts, create tokens, and basically set up your environment for quick testing of your applications. We've also intentionally designed it to work with CI/CD pipelines, so it's like very compliant with like industry practices of testing your applications. And in short, our goal is that by using the CLI, you don't have to maintain like loads of scripts with like a lot of code to like set up your environments. You have to manually copy and paste like your private keys, account IDs between these files. Everything can be managed from one CLI tool, which you can install. You create a couple of scripts and that's it. So a couple of key people that should start using the CLI tool are like people that really enjoy automation. They have like a lot of repetitive tasks that they want to automate, and they're using scripts for this. Another key user here is like Hedera projects that have like these kind of CI/CD pipelines, and they want to automate it more for end-to-end testing. And also, it's a great tool overall for like people that are new to the ecosystem or they want to explore our technology. You can easily play around, create accounts, create tokens without really having to dive into the actual code. So it's also a fun way to explore the technology and see what's possible, how you can transfer tokens, how to create NFTs, how to create topics. So it's great for this as well. So for those that actually know the Hedera CLI, it actually moved from Hedera to Hiero as well. So now it's under Hiero. And a couple of things have like really changed. The first thing that has changed is that we actually decoupled the architecture and we made it much more modular. So now we have like a core API that exposes actually like a lot of typed APIs. And basically these typed APIs are like a thin wrapper around the official Hedera SDKs. And they ensure that all the calls that you actually do from the plugins that we later built on top, that they're all consistent and they follow like a well-tested interface. So there's no funky things happening in this core API. To give you an idea of like which kind of services that we're offering, for example, like a very easy to understand service like the account service, you need to create accounts on the Hedera network to be able to interact with it. So the account service contains a lot of standard methods to create accounts, to view accounts, to list them. So other services are a bit more abstract. So for example, we have an alias service. Within the state of the CLI tool, you can give every entity an alias. For example, a token can have a name. You can call it token1, or you can give like your accounts a name. You can have Alice, Bob, all these names in your CLI tool. And this makes it a lot easier to also write scripts and to reference the right entities that you want to interact with. So instead of having to manually copy and paste all these account IDs or private keys, you can just reference people by the alias within these scripts. And then other interesting services are like an HBAR service, but also, for example, a KMS service. So this service makes sure that all keys are handled safely. You can update state, you can retrieve keys, and you don't have to write all this logic yourself. So the ultimate goal is that like all the logic exists. And when you're creating maybe like a custom plugin, you don't have to reinvent the wheel. You can use these existing functions and build the stuff you actually need. And the second thing then what happened is that we built like an ecosystem of plugins. We are providing a lot of base plugins for like interacting with tokens, creating accounts. All these things are covered, but this also leaves the option to create custom plugins. And by design, plugins are always stateless, so there's no local plugin data. But we do have like a state plugin where everything is securely controlled, where all the data lives, and it also enables like more deterministic behavior when you're using it in a CI/CD pipeline. So if we dive a little bit deeper, I want to show you like what's the architecture of an account plugin. You can see there's always like a manifest file. This file defines like all the options, all the commands that exist. If something doesn't match, the plugin can't even be added to the CLI tool. So everything needs to be defined upfront, and it will be validated by the CLI tool. There's a schema which also defines like all the input, output variables, and it's also tested all the time. And then there's like this command folder where you can have a folder per command. So we have account create, account import, account balance functions. And each of these commands, they will have like a handler where you write the actual logic. And then we also have like an output file where you define like the output message. And for example, you call the retrieve balance function for an account. How should the CLI tool format like the data and show it to the end user? And there is also like an index file which just exports like all the commands. So that's the architecture. Here's like an example of this plugin manifest file where you can see like all the options. A little bit small, but you can see this is like the create command. And it defines like all the options, like the balance option, which has like the B option, and it's like a type string. So everything is defined here. And then the final thing, or the ultimate goal as well, is that you start building like your own CLI tool and your own plugin. So for example, you have like an application on mainnet and you want to allow people to easily interact with it. You could build like your custom plugin, drop some of the plugins you don't need, and add your own plugin to the CLI tool. And you can actually release it as your own version or your own CLI distribution, as I would call it. So that's like a really great thing, that you can build custom CLI tools that are like domain specific or application specific, and you can release it to your community. And everything can be done through this plugin management plugin. So this plugin is mainly in charge of like adding and removing plugins to the state and to the CLI tool. So I will give like a quick introduction to some of the plugins and also the scripting feature. So these are the core plugins. So the first one and the main one is the network plugin. This plugin allows you to easily switch between the different networks on there. So you can go to the testnet, preview net, or the mainnet. And for each of the networks, you also have to set an operator account, which will be the payer account for your operations. Then we have the account plugin, which covers like the basic functionality of creating accounts, but you can also import accounts, you can retrieve the balance for them, and you can do loads of other actions as well. Then also HBAR transfers are covered. And then we have the token crate. Token crate is quite a advanced one because it has loads of options, setting admin keys, custom fees as well. Not all these options are actually covered in this basic command. And we also have like a couple of other things like the token create from file. So if you take a look at this one, the token create from file allows us to create tokens with like a lot of configuration options. So basically it's a specification file where you can define all the options for your token. So it's like a token definition. For example, you can see there is like a key section where you can define all the keys on the token, admin keys, supply keys, or freeze keys. You can set it to an alias that lives in your state, or you can just say like which is the key type, for example, ECDSA key, and then a column with like the private key attached to it. So both options are possible. The cool thing as well is that you can already define the associations. So you can say I want to associate account Alice or account Bob by default with the token that I'm about to create. So this is like a different option of creating tokens that have like a lot of configuration options, including these custom fees, which are really hard to add to a CLI tool, like do your command in command line. Then the topic plugin is also covered. It covers like basic command again, like creating new topics. It has like topic list, but it also has like topic find message command where you can filter by sequence number and also submit messages to a topic. And then finally, the one that I already discussed is the plugin management, where you can add new plugins or remove them from your state. This basically allows you to create like a trimmed down CLI tool, which you can release as your own distribution. So then the better feature that I want to show you is scripting. So sometimes you can say I want to create like my own custom plugin. This might be super useful, but the scripting functionality also solves the problem of having to create your own custom plugin and really need to understand the architecture. So this is an easier way to write custom logic around the core API commands that we are actually exposing. So a script is basically a bash file where you can create, where you can call any of the commands. And the first part of these scripts always start with loading a couple of helpers that help us to format data or print messages in a nice way to the terminal. And once you have loaded the helpers, then we actually call a wrapper. So here we have an HCLI wrapper, which calls this folder where the CLI tool lives. And then it passes any of the arguments to our CLI tool. And so from there, we can actually start creating scripts and calling all kinds of things. So we can call the network use command where we want to switch to a different network. Then we can use the network set operator, and we can continue building our CLI tool. Well, the script file with like loads of other commands. I think I have more here. Yeah. So we can say I want to create an account. We can create multiple accounts in the script. We have like a helper that actually picks like a random name, so you can create different names. You can do transfer between these accounts. We can view accounts. So the real benefit is that you can create these automated flows that really set up like your testnet environment. So you can create 5 accounts, you create a token, you automatically associate Bob and Alice with these tokens. And you have your environment ready, and you can start testing your applications, running end-to-end tests. Let me go back here. Yeah, so that's really the powerful feature here. And that's why I'm telling you, like, you don't always need to write your own custom plugin, because the scripting feature really allows you to do a lot of things. So what about the future? The CLI tool is in a good base state. You can install it through npm. You can install it globally. So it's a really good place. But now we're working on smart contract deployment and also the verification. So we're adding functionality to deploy ERC20 and ERC7 to one contract, as it's really essential for Hedera and also our EVM. And then we're planning to support many more features like the batch transactions, which we recently released, scheduled transactions, NFT plugin is almost complete. And then we're also looking at a couple of smaller developer experience issues where we want to like scaffold projects or like make it easier to initialize the CLI tool. And in the end, our end goal is to like create an environment where we have a lot of plugins that are application specific, where community builders are like creating new plugins that make lives of our developer community a lot easier. So if you have any feedback or you have ideas or you want to learn more, you can go to the GitHub repository, which you can find under Hiero Ledger and then Hiero-CLI, or you can also scan the QR code. So that's it for me for the CLI tool updates for today. Thank you.
All right. Thank you so much, Michiel, for that overview. That was pretty awesome. And so I do have a few questions that we've seen come in prior to the session. One of them is there's this modular approach that you covered with the plugins. And so could you mention maybe some of the benefits or considerations of going modular with the plugins as opposed to, a monolithic monster code base approach?
Well, it was way harder to. Well, first of all, like plugins were not stateless when I created the initial version of the code base, and everything was like tightly coupled. It was really hard to add like custom stuff to it. So now when it's like decoupled, we can just like say we throw away one plugin that we don't need. We can add our own custom logic. And by defining like schemas, and we add more validation, it also became more secure. Because before in the monolithic approach, you could create like a plugin that could like could read like the complete state and steal it basically from your application if you installed like a malicious one. So now the state is way better protected. Plugins have become stateless, so there's no chance for them to like really steal data and get it out of it. So that's one of the biggest benefits that we got out of it. And also like it just makes it easier to develop stuff on top of it, because we have like this core API now, and developers can build anything they would like to in the end and make it like application or domain specific as well.
Absolutely. Excellent. You also told us where to get it, which I love the fact that it's available through NPM.
Yeah.
I think, most, if not all developers are pretty familiar with how simple that process tends to be. And so in addition to finding it on NPM, installing it, how can developers start using it, and, what resources are available to them in terms of documentation or other support materials, if you could briefly comment on that?
So all the plugins are basically covered on the repository at the moment. The PR for the docs on our official documentation is in review, so I'm expecting it to be published this week. But no, you need to understand, like it's like a living project, so we're constantly making changes, adding things. But yeah, the repository documentation is like the most up-to-date documentation to get started at this point.
Excellent. And you mentioned you're also looking for that ecosystem of plugins where maybe there are contributions that are not only from Hashgraph or core development teams, but also from community devs. And so could you comment on who can contribute and how they would go about getting more information about that?
Yeah, so anyone that actually, you don't really have to deeply understand Hedera to build a plugin. Hedera Hiero to build a plugin, because you can also create like a very simple plugin that does like batch creation of accounts. Basically, anyone that is able to program using JavaScript and TypeScript is able to contribute. they can open a PR against the repository. Our team will like review with test the plugin, make sure it fits like the quality standards. And once we agree on the plugin, we can actually merge it, or we can create we add it to a repository of like community plugins where people can install it, because we don't want to always add like these custom plugins in our core because it would like dilute it basically. So you can download it and install it, but it won't be added to the core services.
Understood. All right, that perspective of Hiero and Hedera is very interesting. In fact, we've had Hiero before on this call, and for this next question, I do want to bring Keith to the stage. Keith, if you could give us maybe a 20-second explainer on this relationship or connection between Hedera and Hiero, that could help us understand the landscape and the opportunities for contribution. So it would be great to hear from you about that before we dive into hooks.
Yeah, for sure. So for most of Hedera's history, we have been open source. But last year we took the added step of setting up an organization within the Linux Foundation Decentralized Trust, which is called Hiero. So Hiero is now like the new organization under Linux Foundation, where we have moved the bulk of our source code, consensus node, mirror node, JSON RPC relay, Hedera CLI. All of these projects sit under Linux Foundation now. They are governed by Linux Foundation, rules and procedures. And, it's a very open environment where anyone can contribute to not only to the Hedera CLI, but you can contribute directly to the Hedera consensus node. So it's an amazing environment. We have community calls. We have TSC meetings where we present HIPs. So I would definitely encourage everyone to get involved, to check it out. It's a really exciting open source environment for the Hedera and the Hiero and Hedera ecosystem.
Amazing. Thank you for that explainer, Keith. All right, so that was the segment Q&A or the break Q&A. Now let's dive into the second portion of the session, which is the deep dive and overview of Hiero hooks or Hedera hooks. So Keith, over to you.
Great, thank you. All right, I'm just assuming everyone can see my screen. So today I'd like to introduce Hiero hooks. Often within Hedera, we also talk about them in terms of like their original HIP. In this case, it was HIP 1195, but I'll try to be good and talk about this in terms of the product name Hiero hooks. So here's just a quick agenda. I'm just going to talk a little bit about, why did the community come up with Hiero hooks, some of the core concepts, some of the first early implementations. I have a quick demo, and then we can talk about what's coming next and some of the exciting future possibilities. So I think the best way to talk about Hiero hooks is that today, on Hedera and many other networks, you kind of have a divide. You have native services like Hedera token service or Hedera consensus service that have very kind of fixed protocol behavior, and that's good in many ways because what they're going to do. Everyone understands, is on the same playing field about their behavior. They're very fast. And they're very easy to interface with. And then the other side of it, you have smart contracts, which have this amazing programmability layer. But then you have added concerns about like security, or to actually interact with the smart contract. It's a level up where you actually have to be making smart contract calls or things like that. So hooks is really, I think, a groundbreaking hybrid approach. I think it's one of the first, if not the first network to bring in this kind of hybrid approach, where you can actually add programmability directly to native entities. And by native entities, as I'll explain later, most of what we're talking about here are accounts and tokens. So basically, we bring that smart contract flexibility to native services while still retaining the performance, the ease of use, and the trusted behavior of native services. So just to go a little bit deeper, what are Hiero hooks? They are entity-owned executable logic, or as I said before, like by entity, I mean usually accounts or tokens. They are they're executed automatically when specific native operations occur. They are defined by Today, they're defined by HIP 1195 as a general extensible framework. So the initial implementation is using EVM bytecode, and that's what I'll be focusing on in this presentation. But in the future, they could be programmed in other ways. That's pretty extensible. I think as we talk about this, I think there is an important concept that I'd like to, as I describe what hooks are. Hooks are actually made up of two important components. There's extension points. These are basically like, in the consensus node, we've actually added in, points where hooks can interface. And this actually requires changes to the consensus node itself. They are fixed in location. They have a fixed ABI and semantics, and they decide what custom logic may or may not run. So you start with an extension point to enable a hook, but then you have the hook itself. And the hooks are written by users. They're very extensible. You can kind of do whatever you want with them, but they are bound by that extension point that was added to the consensus node. So, just to say, because we are tying into native features, you need that extension point, but then you get that programmability of the hook. So, in this sense, users, you can create your own hook, and you can also create your own extension point. But to create your own extension point, it has to go through the HIP process. It has to be developed. It has to be added to the consensus node. So, that's a little bit more of a process than just writing up a Solidity smart contract. Some kind of just quick, I don't want this presentation to be too technical, but, just a few little fundamentals of hooks. They do execute in a specialized EVM environment. They execute with the privileges of the owning entity. The transaction payer covers the hook's execution cost. And as I kind of have at the bottom there, the execution cost, just to kind of get that one up front. If you're adding or deleting a hook to, let's say, an account, it's $1. If you're invoking a hook, the proposed price is 0.005 cents plus gas. And you could always implement logic, refund logic. That part's pretty flexible. In terms of the state and storage model, each hook has its own isolated storage, and we'll talk more about some of the power of that. We've actually added a new transaction around that called hook store. So it's lower overhead than, let's say, than a contract call, or well, I guess that's about it. There's lower overhead than a contract call. But yeah, you have that programmability flexibility. So how do you use hooks? Well, the way you would use hooks is actually mostly through our existing transactions. So when you do crypto create, and this is kind of shorthand, but that's crypto create is how you create an account on the Hedera network. When you create an account, you can kind of attach a hook to that account. Or if you have an existing account, you can use our crypto update functionality to add a new hook, or to modify a hook that you already have attached to your account. The only new transaction we are adding around Hiero hooks is this transaction called hook store. This allows you to update the hook storage directly, but it does not execute hook logic. I mean, again, this is very powerful because it means that you can, instead of, you always have the complexity of smart contracts about how do you update them. And this just makes it very easy to update the state of your hook. Now, there's a caveat to that. Smart contracts, again, depending on how they're built, you often rely upon, the auditability of them, the behavior of them. When it comes to hook, for the security model, everyone needs to understand that the hook that's attached to the account, well, the owner of that entity, whether it's an account or a token, they own that hook, and they can modify it at any time. So it's just something to think about when you're thinking about the security model of hooks, because it is a little bit different. I mean, again, some smart contracts are like that, but that's always something you have to consider is like, well, what are the parameters in which you can change the state of the execution layer, or of the programmability layer. And then finally, how do you call a hook? How do you execute a hook? Well, they're never called directly. Execution always happens within native transactions at predefined extension points. And we're going to be talking in my next slides about the first hook we've launched, which is the allowance hook. So for the allowance hook, it's only executed when you do a crypto transfer transaction. So it's during, and that's where you can invoke that hook and activate the behavior of that hook when you do a crypto transfer. So as I mentioned, the first extension point that we are launching with HIP 1195 is called the allowance hook. This really offers, very powerful capabilities around crypto transfer, as I mentioned. And it, if you had to boil it down, it kind of just says you can have all sorts of really cool programmable logic that ultimately decides whether or not a transfer should be allowed. So, the transfer will reference a specific hook. The network will, reaches that extension point. The hook bytecode executes, and then some sort of Boolean returns. This is more in the internal consensus node, whether or not that transaction should happen or not. It's atomic with the transfer, and it can often, obviously, if a transfer doesn't happen, that it will just fail. So what does this enable? I mean, the sky is the limit because again, it is programmable. I think we're excited to see what the community comes up with for this. But you could do things like conditional spending rules. You could do protocol and fenced access control, permissions, and then programmability without custody transfer. So I have a demo for this, and of course, with all demos, I had to come up with a fictitious scenario to kind of demonstrate to people the power of this. And so, I've chosen a simple demo just to kind of help explain the functionality of this. So let's say we have a DAO and they hold 1,000 tokens, and they have a desire that they want in their treasury, and they want to distribute, rewards from that treasury to community members. Okay, so how would this work today? I mean, today, those tokens would have to be transferred from the DAO. People would have to have signing keys for the treasury account and to be able to transfer those tokens from the treasury to, in this case, community members. Now, often, you would never, from a security perspective, you would probably not want a single person to have the keys. Maybe you'd have some sort of multi-sig key structure on that account as enabled by Hedera. And then that requires you have to go through some sort of complex signing coordination. So Hiero hooks, because again, it's this hybrid, it allows a different approach where the treasury DAO can now decide that, yes, they want to give 2 of their community members, 2 stewards, the access to the treasury and the ability to transfer rewards to community members, but they want to put some restrictions on it. They say we don't want a steward member to be able to drain our treasury account. So they're limited to only being able to distribute a small number of tokens cumulatively. So that treasury account, the DAO, can deploy a hook to their treasury account with that programmable logic to say, look, only these 2 stewards can transfer tokens to, they can transfer tokens to whoever they want, but they can only do it up to 100 tokens. And obviously, you could do a lot more restrictions or things like that, but this is just a simple example. So this demo is intended to show how we can use Hiero hooks to extend the functionality of crypto transfer with programmable authorization. So let me just show you the demo. Now, I'll say up front, I'm a bit of a chicken. I don't like doing live demos. So actually, I've built this demo. This is a demo that I built using our Java SDK and functionality on one of our production networks. And basically, I've actually already run it. I ran it last night just so it's all ready to go. So basically, this demo first, sets up the demo environment. So for this scenario, I created a treasury account. I created the stewards accounts, steward 1 and 2. I created the delegate or the community member that we're giving the rewards to. I created a fungible token, the DAO token that sits in the treasury account. I deployed a hook to that treasury account. And then, I did 2 demos. The first demo was steward 1 transfers 20 tokens to the delegate, and that passes because it's that's the power we gave that steward, is that they can transfer 20 tokens. The second scenario is you have a malicious steward 2 is malicious. They want to drain the treasury account, so that person tries to transfer 500 tokens out of the treasury account, and as expected, it fails. This is a little mistype in my transaction. It fails because that's not allowed. So what does that look like? And I'm going to use Hashscan to kind of just show what that looks like. So I created all those accounts, And the first thing I did was deploy a hook to that treasury account. So here's that transaction. But more importantly, here is that treasury account, account 3183. And we can see that there's a new box here that talks. So there's a hook been deployed to that account. Now, what is that hook? That hook was a piece, that was some Solidity code that I wrote up. This is the actual my hook that I wrote in Solidity, and then I deployed that as bytecode to that account, and that makes up the hook for that account. So here we have the treasury account. Here's its hook, and then as I said, we did 2 tests. That first test was that first Stewart 1 submits 20 tokens to the delegate, and then that should pass. And so here we see the transaction. This is a crypto transfer. So you can see what's very interesting here is delegate 1, their account number is 3184. So, they paid the fees and stuff. But the actual transfer of 20 tokens came from that treasury account, 3183. It transferred to that delegate. So here you see hooks in action. This user, the Stewart 1, was able to do the crypto transfer, but the actual tokens came out of the treasury account of the DAO and went to the user. And then here's that second failed scenario where, again, we had that malicious user who tried to transfer 500 tokens. And again, because of the way that I wrote the smart contract, it said no, like they can only Stewart can only transfer up to 100 tokens in total. So then this transaction was rejected by the network, and you get this message like rejected by the account allowance hook. So that's a quick kind of demo about, how, again, this is a very simple demo, but I think that kind of illustrates the power of hooks. And, and this is, obviously you can go a lot of places from that. So what are some future hook use cases? I mean, again, the sky's the limit. Maybe DEX order limits without token lockup, business treasury escrow, controlled spending for dependents or employees, which kind of goes to the demo I just showed. Conditional payment acceptance, crypto inheritance patterns. It's programmability without custody transfer. It's a very powerful. And so just to kind of conclude, I encourage everyone to let's start the hook journey. As I said, hooks are defined in HIP 1195, and I'll just click over to that just in case of people are not familiar. We have this website, hips.hedera.com. You can see all of the new features coming to the Hedera network, and then you can see a comprehensive write-up with a lot more detail than I provided in this meeting about exactly how Hiero Hooks works on the network. So HIPs are a great reference to help understand a new feature. Hooks will soon be available on our network testnet. So I really encourage you to test out hooks and provide your feedback to the community about what you like, what you don't like. We'd love to hear about what applications you want to build for hooks, because we're very excited about this feature and we want to make sure that everyone else is excited about it as well. And then finally, again, we've only launched the allowance hook to date. So if you have exciting ideas about ways that we can extend native transaction functionality, whether it's tokens or accounts, please propose your own hook extension through the Hedera HIP process. We'd love to see your ideas. And I will just pass back over to Ed, I think, if there's any questions.
Excellent. That was an amazing overview, Keith. Thank you so much for that deep dive, the overview, and also the demo that you put together to bring and share this knowledge. We do have a couple of questions from the audience. So maybe let's start with this one from Easton Villa, which is, what is the transactions per second or the throughput through a hook versus a full execution on EVM?
Well, this is a bit of a complicated question because historically, smart EVM operations have been governed by an overall gas limit on the network of 15 million. Now, that is, in fact, changing in this release, HIP 1249. We're actually bringing in a new throttle model. But yes, the execution, Hiero hooks are, their Solidity smart code. They are executed within our EVM environment. You do pay for them in gas. they do fall under our existing gas throttles.
Right.
Hopefully that ends. And then also, like, we also have like throttles on happy transactions like crypto transfer. Now, the throttle on crypto transfer, I think, is 10,000. That would not impact you. But for other transaction types, in the future, for other types of hooks, you would probably think about the gas throttle and the happy throttle.
Makes sense. So in a way, you are able to leverage the scalability, the speed of the native entity, but you just add that programmability layer, that additional flexibility that the hook gives you through that EVM execution layer in a way. And then the throttles apply in the same form in that paradigm is the way that I'm understanding.
And something I didn't mention, but so it's also one of the benefits, often smart contracts, can be quite big because they need to be fully self-enclosed. So they consume a lot of gas. Hooks by their very definition are very lean. Very simple. They don't take that much gas typically. You could maybe write a huge smart contract, but like or a huge hook. But normally the hooks that I've seen, they're quite simple. They don't take much in terms of gas.
Excellent. Keith, another question is, I agree completely that this is game-changing functionality, as you said. I'm also not aware of a lot of networks or any networks that combine that scalable approach of the native entities with that programmability and flexibility of the EVM with the hooks. And so my understanding from the HIP is that hooks act like a programmable signature substitute, right? So effectively it executes with the privileges of the entity that owns the hook. And so from your perspective, how should developers think about security when using hooks and, thinking about these owner privileges within the hooks code?
How I think about the security model is that it really rests on the security of the entity that controls the hook. So let's just go back to my example, like that DAO. Like the hook is deployed to the DAO account. So if you have a DAO, if let's say to do changes to the DAO account, it requires like some sort of complex multi-sig. Well, then that's your security mechanism. Like you can trust that the hook is not going to change, because to change that hook is going to require like 10 signatures of the DAO account, the DAO treasury account multi-sig. But, if you're dealing with like an account that maybe just has a single owner, then yes, you have to just understand that like that owner can change the hook behavior at any time. That's just like rolled into the thinking about it. So it's the security model of the token or the account. It's not the security model. Like the hook inherits that security model.
Makes sense. Makes a lot of sense. All right, Keith. So I know you covered this towards the very end, that if people want an additional hook that they want to propose to the community, you mentioned the flow, but I just want to make sure that people are very clear on what that process looks like, where they could go. So if you could walk us through that process again, if people want to propose new HIPs, could you tell us where they should go, how they should think about that, and how they should go about it?
Yes. Yeah. So on the HIP process, so anyone can propose a new HIP. I want to make that very clear. We have, if you go to hips.hedera, particularly, I would start with what we call HIP 1. HIP 1 actually describes the entire HIP process and what you need to do a HIP. But in simple terms, for developers, you just kind of clone the Hiero improvement proposal repo. You add in your HIP, you do a PR, and then that process kicks off. Now, the HIP process itself, you start out in draft phase, then you can move into review phase, and you move into final call. And it ends with you bringing that HIP to the Hiero Technical Steering Committee, or TSC. And you will present your HIP, and they'll decide whether or not they want to accept it for the Hiero network. Now, just because you get a HIP approved, though, then like that's part of the process. But the other part of the process is, well, somebody actually has to develop it, like whether you're adding code to the consensus node or the mirror node or whatever. So maybe that's a project that you take on, like you want to directly add that code to the consensus node. Amazing. Or maybe you're looking for a Hashgraph to pick up that HIP and do the development work. Well, then that will require some more communication. Like Hashgraph would obviously have to also see the value in that HIP, prioritize it, and get it into the development pipeline. So I'm not going to, I think it's a process. If you want the mental model for this, it's the same basic, it's based off of EIPs. So it's the same, and so it's the same, some of the same dynamics of EIPs as well. When you think about that in Ethereum improvement process, we've really modeled on that, the Hedera improvement process on that.
Excellent. Thanks, Keith. So before we move to our outro and closing thoughts, Keith, I want to, get your thoughts on this, but what are some of those additional hips that may be on the product roadmap, without commenting on timeline, because maybe some of these are not approved yet. But what have you seen in the product pipeline in terms of hips that are being proposed that, make you excited for what's in store in 2026?
Oh, I hate this question. I have too many hips in my head. And also, sometimes the hips that excite me are not going to be the hips that excite everyone else, because, it's a lot of times it's like more hips are more aimed at like internal network improvements versus like something external that you can touch and feel. So like personally, I've been working on a lot on the recent hips I've been working on are a hip called simple fees. That's where we're kind of rebuilding how we do fees within Hedera. That one's coming up quite soon. Personally, I think that's going to make the whole fee experience on Hedera much more understandable. And I'm very excited about that. But that maybe, for most users, they won't really see a difference, so it won't impact them. There are the Pectra hips coming. That's making sure that the Hedera EVM is aligned with the latest changes in Pectra. And something more we might be talking about is there's a hip being proposed right now around the delegation based on EIP 7702, I think. So that actually is very. At the surface, it looks very similar to Hiero hooks, but actually at its core, if you actually go deeper, it's quite different. But yet it goes on this train of like adding programmability to native transactions and really opening up exciting opportunities. So there's probably a lot more hips I could talk about, but I think those are two that I personally am working on. So that's where my brain is at right now.
Makes sense. It's certainly a difficult question. From my perspective, I also want to give a quick highlight to TSS, Blockstream, and Blocknotes. I think that's another one that is going to be a big one in 2026. So very excited about the benefits and scalability or simplifications that that could bring in terms of efficiency gains as well. But my point as well with that question is this is the place where we would love to bring you again, Keith, and also some of the other experts in the community in Hashgraph to share this knowledge with the developers and the builders in the ecosystem so that you can stay tuned about these upcoming developments and new hips and new features as well.
For sure. Anytime.
Awesome. All right. So I do want to welcome Hiel back to the stage. Let me check if there are any questions coming from the audience. Doesn't look like it. And so, I just want to give this chance for any closing thoughts from our presenters today. So Keith, we'll start with you in case you have any last messages or important notices to share with the community, and then we'll go over to Michiel with that same closing thoughts.
I just want to thank everyone on the call for their time. I'm really excited to have joined this call and presented on this call, and I hope please keep your ideas flowing. I would just say, as a product manager at Hashgraph, we want to hear your ideas. We even want to hear your complaints. We want to work to make the network better. So as a product manager, please keep your input coming.
I would say the same. So if you find any issues with the CLI, just test it, try to break it, and let us know in the issues section so we can follow up and improve it. So thank you all.
Awesome. Thank you, guys. And in terms of where to give feedback, you heard it. I think the GitHub repositories, whether it's Hiero, repos, also Discord is a fantastic place to get in touch with our frontline teams and also community experts and ambassadors and primarily moderators that can help out. And so please join the Discord as well. If you just go to hedera.com/Discord, that's a great place to get in touch with technical and community experts. All right, so now let's do a quick outro. And I do want to remind you again of that Apex Hackathon that is going to start on February 17th. Again, $250,000 in prizes and opportunities for those winning teams. So that's going to be virtual, remote. You can join from anywhere. And so looking forward to seeing new hackers and also returning developers in that hackathon. Also, Dev Day on February 17th, if you're going to be in Denver. Looking forward to seeing you there and enjoying the talks, workshops, and hands-on sessions that are going to take place there. And finally, I do want to remind you to tune in for the general community call that we have happening tomorrow at 10 a.m. Eastern time. We're going to have the CEO of Kabila and also the head of Headstarter, both of which are fantastic Hedera projects. So stay tuned, and looking forward to sharing a lot of this technical and community information with you throughout the rest of this year. So last but not least, I do want to thank the guys behind the scenes. So Luis, Fermin, thank you so much for organizing this call, for making it run smoothly, and for all the support that you've provided in all the calls that have happened and the ones that are to come. With that, everybody have a great day, and thank you for tuning in.
Thank you.
Thank you.